Buenas tardes. I promise you this talk will be in English. Introduciendo al señor Josue Coronel, el título de su presentación, Building Workflows with Celery.
So yeah, we'll welcome Josue Coronel for his talk in English.
How's it going, everybody? So let's start. Well, first, my name is Josue Balandrano Coronel. I work for the Texas Advanced Computer Center at Austin, and I'm also a small part of the core team for Celery. So let's start with this hopefully very interesting presentation. And first, let's start with a very quick overview of what Celery is for anybody who doesn't know out there. And Celery, it's basically a task queue, which what allows us to do is to run things asynchronously. Now, the only thing is that you might be thinking, well, nowadays we have all these different projects like Async I/O and all the different asynchronic world out there. But the very interesting thing about Celery is that it allows us to do distributed things. So run things remotely in other computers. Also, it gives us a lot of different things that we, in a way that we can, for instance, apply a retry policy on different tasks that doesn't run, or they error out, or something like that. And we can also store results in different ways. This is just like a very quick thing, a very quick also way to view how the Celery architecture actually works. And everything starts with our main application, which it's usually what we call our producer. And we call it like that because this is actually what creates or produces all the different messages that are going to be sent to the workers. And the workers are the ones who are actually going to run these different tasks that we're queuing, right? The cool thing about this is that if you think about it, you can run different tasks in different machines that have different resources or have access to other different resources. Inside each one of these workers, what we have is usually a main process and then a number of other worker processes. And this is how we can run things also concurrently. And all of these, actually, the way that they communicate between themselves is using something that's called a transport, which is usually something like RabbitMQ, or we can also use Redis. And there's other supports for other types of transports, even a simple file transport. And we can also use a backend, which is usually what we name, what we use to save the different task results. So how can we start building these different workflows with Celery? Because we have talked on how Celery basically just run different code in remote machines, right? In distributed machines, if you can call it that. So everything starts actually in Celery with what we call signatures. And signatures are basically very related to what Python partials are. They're implemented in a different way, but the idea of it's basically the same. So the way that they work is that if we have a task, for instance, here, the task that we're going to use is projects.tasks.mytask. We can create a signature. We can create a signature from this task. And this signature is basically going to be a representation of what we have here at the end of the slide, which is just a way to actually execute that function itself, which is project.task.mytask with some specific arguments. It could be just like normal parameters or also keyword parameters. The other cool thing about this type of signatures is that they're easily serializable. Sorry, that's really, really hard to pronounce. Serializable, yeah. Is that correct? Okay. Let's just continue with that, yeah. Okay, so for instance, the serialization of this task, of this signature, as we can take a look at it here, it's actually just a very, very simple dictionary. And this is what allows us to actually send this message into our workers through something like RabbitMQ or Redis or any other type of broker. and have that worker know what it needs to execute. So we can see signatures actually starts creating this message that we're going to send. So the message itself doesn't contain any code. And that's one of the things that we have to kind of get a grasp on, because we have to have the code that we need to run in each one of the workers. That way the producer only tells the worker what it needs to run with which parameters, and then the worker does its job. The other cool thing about signatures is that we're able to define different options that Celery actually uses. So for instance, we can specify different queues on where these tasks are going to run. And we have this example here where we're actually setting a custom queue whenever we're creating our signature. Then the other good thing is that we can create a signature, and then after creating that signature, we can set different arguments for it, or we can merge different options. So for instance, here on the first line, we're creating a signature, or well, we're using the signature that we have already created here, and we are actually using another parameter, which is going to be this string called, with the value new model ID. Or we can also set another queue that task is going to go to. Now, this is the very beginning of how to start creating workflows. The other idea that we need to realize here is that we can create signatures in different ways, right? And one of the other ways is to create it directly from the task object. So we can see here there are some shortcuts, which is .s and .si. So .si, well, .s first creates a regular signature, as we just saw, and .si, what it does is that it creates an immutable signature. And that signature will not allow to get any new parameters or anything like that. The other thing to see here is callbacks, because now we know how we can send these tasks to different workers. Now, how can we start creating these workflows? So the very first step of it is to create a callback after one task gets run or one function runs and it's successful. Then we can run something else. And this is the way that we can actually start setting different callbacks. It's very simple. One of the main ways to do it is whenever we queue one task, we can tell Celery to actually run something after it has been successful using the link parameter. The link underscore error, that's going to be the callback, the error callback whenever that task fails. Or if we're creating a signature, then we can actually set these different links or link error to callbacks. Now, after this is the very basic ideas on how everything that has to do with workflows work in Celery. And then it's a little bit hard to just kind of start building workflows with just these two different objects. So Celery allows us, or well, Celery gives us these different primitives, which we can use to start creating better and just a little bit more complicated workflows. The first one is a chain, which is basically what we just saw. It's running first one function, and then once that function executes, we can run something else. So first this one, and then we send the result to whatever the callback is going to be. And this is the way that we can actually define a chain. As we can see here, it might be a little bit difficult to see first, but the way that what we're using here is the pipe operator, operand. Or we can also just use the actual chain function that we can import from Celery. The other thing that we can use is a group. Basically, what we do with a group is that we queue multiple tasks with the same, with different arguments, but they are going to run in parallel, as we can see here in the image. So, for instance, here, what we're going to do is that we're going to run an array of tasks, and they're going to run each one with different parameters, and they're going to run in parallel here. And we're creating this array of tasks here in these four statements. The other primitive that we can use are chords. And these, as we can see from the image, actually it's calling one or more tasks and running those in parallel, and then running a callback after each one of those has been run successfully. And this is basically what we can also call a group with a callback. So there's two ways to create a chord. One is to create a header which is an array of one or more tasks, and then a callback, and execute that. But also, we can just chain a group with a callback, and that's basically the same thing. Celery will know that this is going to be a chord. The other primitive is map, which is something that we can use whenever we have an array of parameters, and we need to run this array on the same task. And the only difference is that it's not going to be in parallel as a group. It's going to be sequential. And we also have star map, which is basically the same thing as map, but is whenever the array has each one of the elements, it's another iterable. So let's start. Let's see which kind of workflows can we create from this. And let's think about whenever somebody logs into an account, and you wanna check if that user is logging in from a new device. So there's different things that we can do in the background. And let's go through kind of just like the requirements that we need for it. First, we need to check if the device has been used before. Then we need to, if the device has been used before, then we need to notify the user, tell that this is a new device, and we need to save that event into a database. These two can probably run in parallel, so we're already kind of building this workflow in our own mind. Then we can send whatever we get from all these different, from these events, we can send it to an external API. Let's say that it's not really external to the company, but it's just an API that another group is developing. So for us, it's going to be external. And let's say that API, I don't know, does some machine learning stuff like outlier analysis or something like that. And then finally, we get whatever response we get from this API, and we post-process it in different ways. We could probably, again, save it into a database, or maybe send another notification if there was, or maybe just flip a switch somewhere. So let's start. How can we start drawing our workflow? First, the first step is going to be just to check the device, if the device is a new device, right? And then we have these two tasks which we already said that we can run in parallel. So we start kind of drawing them here, so we have an idea of the different tools that we can use. Then we're gonna do a call to a third-party API, which is over here, this node, and then we're finally going to post-process whatever response we're gonna get. So the first one is going to be a task, as we were talking about these ones. And then after this, we can use a group in order to run these two tasks in parallel. Then we can, and the result of this group is going to be an array, because the group is going to wait until each one of these tasks are going to finish to go to the next step. Then this array of results are going to be sent to this other task, which is going to be our step 3. And this one, which is basically a callback, is going to post all of this data into this third-party API. And then this response is going to be fed into this last step, which is our last callback. And all of these, we have to put it into a chain. That way, we can go from step to step. So let's take a look at it in code. This is basically how it looks. And as we can see, Celery gives us different tools, all the different tools that we were talking about in order to do this. And it's very easy to read, and it's very easy to write, too. So first, as we can see here, we have our step 1. Then we have this step 2, which is the group that we're running in parallel. Then we have our step 3, which is where we're posting to our third-party API, and then we're post-processing the result from this external API. Now, this is only a very kind of simple example with no errors, and we're assuming that everything is perfect in the world, which is not. So let's try and figure out how can we handle errors. There are different ways, and we can handle it in different levels from within the workflow. One thing that we can do is that for every error, we can just retry one task. Or the other thing is that we can set different callback errors, and instead of retrying the task, we probably flip another switch, or maybe do something else, right? It depends on what kind of error it is. So if we wanna retry the one task, then the only thing is that we can only do it in the task level. We cannot do it in the entire group level. We will have to do it in one task. But Within one group, if we start retrying one of the tasks that are running in parallel, the group is, well, the entire chain is not going to move to the next step until every single one of the tasks in a group finishes. That means even if one of the tasks is retrying and retry. This is one of the ways that we can retry within a task. And it is a little bit manual. There is another way that we can do it, which is setting an auto retry and specify the different exceptions that we can catch. But in my, well, historically, actually, in the different things that we have implemented, we've seen that it's easier to put it this way because it's more explicit what we're actually trying to do. The other thing that we can do is that we can set different callbacks. We can set a callback on the task level. So whenever this step is going to fail, then we're going to fire up this callback. This is one of the ways that we can do it. As we can see, it's the same code that we had before, but we're adding a dot on error, and then the handler. Then we can also do a callback just on one of the tasks on a group, or even we can do it on the entire group itself. So for instance, if we want to do it on the entire group, we can also use this link underscore error, which is what we were looking at before. Or the other thing is that we can also add a callback error for the entire chain itself. It depends. It really depends on a lot of different things, and it's a decision on whatever it is that each team is implementing. This is the way to add an error callback after, or if anything goes wrong in a chain. The other thing to take a look at it here is how can we handle different results. So we have our entire workflow, but we want to go back and we want to check what were the results of each one of these tasks. So the good thing is that Celery gives a specific task ID, which is unique to each one of the tasks, and we can grab that task and use this class, which is called Async Result, in order to grab the result of that specific task. And there's different ways to do it. One way to do it is to use just this Async Result class, and we have to give it a task ID. Then we have to specify which backend that we're using. Usually, it's going to be Redis, or it could also be a database, any other database, or it could also be a RabbitMQ. But that depends also on your needs. And you also have to specify which Celery app are you using because of the different configuration that you can set on each one of the apps. The other way to do it is to use the async result class that comes from the task object. And that way, we only have to give it a task ID, and we don't have to specify the backend or the app because the task object is already bound to a specific app which has configured the backend correctly. So one way to do it is to grab that and then to use the specific task ID in order to get the result. Now these are different things that we can use from the result object, different attributes in order to analyze it. So the first one is how we can get the value of the actual result. Then if we're within a workflow like this one or within a chain, we can go up and down in the chain or in the workflow by using .children and .parent. Now, the only thing is that this workflow is very interesting because the second step is actually a group result. It's not a single task. So the class that we're going to have to use here is called also group result, which is basically an array of async results. And here, it works a little bit different, but most of it's basically the same thing. So for both classes, we're going to have these different methods. The first one is to check if the result is ready, because all of this is running asynchronously, and we don't know when is it going to end. So we can continuously check if a result is going to be ready. We can also check if it's going to be, well, if it has been successful, it's either going to be one task, or if it's a group result, then it's going to check if every one of the results within that group were successful. Then whenever we have an async result, we can get the result, which is which is the method in order that we can use to get the same thing as we were doing when we were accessing result.result. Then whenever we have a group result, we can use .join, which what it does is that it loops through each one of the async results that is inside one group, and it's going to wait for each one of those async results to be ready, and then it's going to return an array of each one of those results. And that was pretty much all the different ways that we can create and manage different workflows in Celery. This is where you can contact me if you have any questions or outside in the halls. Also, the Celery project is going to be on sprints, so drop by to pick up some stickers and or pins. And we also have some stickers and pins right here and front if you guys want to pick up some.
Thank you, Josue.
Hey, in your experience, which processing backend do you prefer, like RabbitMQ or versus Redis or whatever?
Well, in my experience, it's usually better to use RabbitMQ because it has it supports more things and it's more robust. And the only thing is that whenever we're doing, like for instance, this type of workflows, Celery has to send different messages. That you're not going to see those, right? But your backend is going to see it. So if it's an actual implementation of AMQP, then it's going to be more robust and it's going to handle these multiple messages better.
Thanks for the talk. We use some workflows in our work, and we had some bugs, like things weren't being called because of some, like even though we are calling retry, or like messages being lost, even though the configuration kind of handled that. So do you know if this is well tested inside of Celery, or did you have any problems like that? Because we had many bugs on workflows, and kind of right now we are trying not to build so complex workflows for better debugging at production. Do you have any problems like that?
Well, yeah, it's always better to keep your workflows as simple as possible. And we do test a lot of these different things within the Celery project. But there are some bugs around it. I mean, these are very complicated things to implement. So yeah, if you have some bugs, I do recommend you to submit some issues. We're always taking a look at those, even though if we take time. Also, if you want to drop by the sprints and help out, that would be awesome.
Can I invoke coroutines from within Celery? Is that possible?
Can you what, sorry?
Coroutines, like async I/O things. Yeah.
Oh, well, yes, there is a way to do it, but it's not fully supported by Celery right now because it doesn't support all the way to 3.7. We're working on that, and hopefully, soon we're gonna do that release that's going to fully support 3.7. Okay, just one more thing. If you guys are gonna drop by the sprints, we have a lot of different beginner tasks and also advanced tasks. So feel free to drop by and to grab some swag.